is more powerful if we compare with push-down automata than finite automata. No? So other than designing a Turing machine for accepting a language, right? We could design a Turing machine for computing a function also. So to this topic, right, we are going to design a Turing machine which can able to compute a function. So let me just take one function here. Let me take one example. Oh, is a function f of m. Then if m is greater than 2 and then 0 if m is less than or equal to 2. Okay, I have considered a function f of m. I have considered a function f of m where if the value of m is greater than 2, then the resultant will be m minus 2. And then if the value of m is less than or equal to 2, then the result is going to be 0. Okay, this is the function I have considered in order to design a Turing machine. Now, before we begin this designing of such Turing machine, right, let me just explain like how we are going to consider an input for such kind of Turing machine, and then any other symbols are required for this one. Let me just introduce about that one. So in this one, right, uh, let me just take few example, like not few, just one or two. Like here, I told that if m is equal to 1, the resultant is going to be 0. If m is equal to 0, the result will be 0. If m is equal to 2, the result will also be 0. Okay, this is my explanation for this particular function which I have just considered, which is f of m. And then if suppose if the m is equal to 3, then the result is going to be 3 minus 2, which is 1. Again, if m is equal to 4, then the result is going to be 4 minus 2 is equal to 2. Okay. But in our Turing machine, right, we cannot insert this 0, 1, 2, 3 like that. If you want, you can do it, but we have to simplify the things. Okay. We have to think about a general solution for all the functions. So now in our case, right, I'm going to use 1 to represent the input because I'm going to deal with numbers. So I just want to represent numbers alone for representing the input. So I have used 1. In certain textbook, they have used capital I for input, then capital O for output. It's up to you. It's up to you. Okay. And then what will be how to represent the output? So the output will be after processing, right? Whatever remains in our input tape, right? That will be the output. Okay. Now, if I consider m is equal to 3, then we are going to perform subtraction like this. 1, 2, 3 will be counted as 1, 2, 3. Then from that 3, subtract this 1, 2. Okay. Now, what about this one? How to represent this one? So from today onwards, right, we are going to use one symbol which is known as delimiter. We are going to use a symbol which is known as delimiter. What is the purpose of using delimiter means? For example, this is the input 3. I just want to represent it here. Okay. Again, if I want to represent 4, then 1, 2, 3, 4. And then if I insert 0, then this is a number I'm representing here. So delimiter means I'm going to signify that from the beginning till this part, I'm representing a number. Okay, it's not that delimiter has to be used only for numbers alone. It's up to you. It's up to you. Okay. So now for this particular example, right, let me take an input of 1, 2, 3, and then a delimiter 0. If the m value is greater than 2, then the results will be this. Hash is being used to represent a blank symbol. Okay. So now how we are going to perform the subtraction for this one means initially this will be at let me just use a better space here. Now let me take the example here. Oh, 2, 3. 1, 2, 3. I'm going to use m is equal to 3, delimiter 0, then this one. Okay, this is the case. Now what I'm going to do is, I'm going to cancel the things. Let me just start it from Q naught. Initially, what I'm going to do is this Q naught. Initially, if you find 1, then cancel it. Okay, cancel it, and then start moving towards right side. And then start moving towards right side till you find the first hash. Okay, for this part alone, let me draw the transition diagram. Initially Q naught, initially you find 1 in the input, replace by blank symbol, and then start moving towards right side. Now, when you move, like initially at Q naught, inside the input tab, if you find the first one, you are canceling it or erasing it, you're replacing that one by hash symbol, and then you start moving towards right side. While moving from this part, from this to this, right, you're going to come across 1, 0, this kind of symbols here, but you did not do the modification there, keep it as it is, and then you need to move till you find the hash. Okay, so for this one, right, I'm going to insert a self loop here. So while moving towards the right side, if you find 1, let it be as it is, and then keep moving towards right side. Again, if you find 0, do not disturb it, let it be as it is, and then keep moving towards right side till you find hash. So let me write the state till you find hash. Now, after finding this hash, what I need to do is I'm not going to modify the hash, but simply I'll move towards the left side immediately. Okay. So what I'm going to do is, if you find hash, let it be as it is, and then immediately move left side. Okay. Now, if you what is my purpose of canceling means I just want to cancel 1 here. If you are going to cancel 1 here, you have to cancel another 1 there. Again, if you cancel another 1 here, then cancel another 1 there, and the remaining will be the resultant. That's it. Okay. So now once you find hash, now immediately move left, and then when you move left, if you find 1, then cancel it. Okay. So what let me just write it here. 1, 2, 3, 0, 1, 2. How to perform the subtraction means cancel this one. If you cancel 1 here, cancel it here, again cancel it there, then cancel it. The remaining 1 will be the output. Okay, this is our purpose for designing this Turing machine. Now, if you find 1, let me just Q2. If you find 1, cancel it, replace by hash, keep moving towards left side. Now, see here, if you find 1, replace by hash, then keep moving towards left side till you find hash. Okay. Now, while moving from this towards this till you find the hash, right, you're going to come across many symbols of ones and zeros. you need not disturb those symbols. So let me just write. Once you find 1, replace by hash, and then keep moving towards left side, and then keep moving towards left side. So while moving towards left side, while moving towards left side, you're going to find many symbols like 1, do not disturb it, keep moving towards left side, 0, you're going to find it, let it be as 0, keep moving till you find the hash. Okay, till you find hash. Till you find hash. So now once you find this hash, right, what we're going to do is we're going to move towards right side immediately here. Okay. Now let me just write it. Now it's a recursive process. Now till we find hash, once you find hash, what we're going to do is once you find hash, we're going to move towards right side, and then in the right side, if you find 1, then cancel it. So it's repeating. Okay, it's recursive in nature. So instead of extending there, what I'm going to do is it's a recursive process. So till you find the hash, so let me just do it like this. If you find hash, let it be as it is, and then move towards right side. If you find hash, move towards right side. In the right side, if you find 1, then you're going to repeat it. If you find 1, cancel it like this. And then if you find 1 zeros on the way, keep it as it is. Keep moving till you find hash on this side. If you find hash on this side, what I'm going to do is, if you find hash on this side, what you're going to do is come back, move towards left side, once you find hash here, if you find hash here, move towards left side. In the left side, if you find 1, cancel it. Okay, cancel it. And then after canceling that one, keep moving towards left side. While moving towards left side, wherever you find 1s or zeros, keep it as it is till you find this hash. Once you find the hash, keep moving towards right side. And then I'm repeating here from here again, okay? Once you find this 1, place by canceling this. Okay. Now here comes the critical point. Here comes the critical part. See here. After canceling, after this, I'm repeating the process. But when I'm going to stop is once after canceling this 1 by hash, after canceling this 1 by hash, this part, okay, 1 by hash, I'm moving towards right side. If you find 0, don't do anything, just keep moving towards this side till you find hash. After finding this hash, what I'm doing is I'm moving towards left side. Okay, I'm moving towards left side, but in our case, instead of getting 1, I'm going to find 0. Okay, now here this part, instead of finding 1, I'm going to find 0. So what will happen is, let me just use different color. So instead of finding 1, we are going to find 0. Now see here, in this particular diagram, we have cancelled all the 3 ones. And then when I was about to cancel the third one on the right hand side of this delimiter, there is no more ones there. But when I started designing this particular Turing machine, what was my explanation? At the end, number of ones to be present, to be left out in the input tab, right? That will be representing the output of it. Now only zeros been left out. We could not able to cancel any further 1 on the right hand side of this delimiter. So this 0, right? This 0 will be converted to 1, and then it's up to you. You want to move towards right side or left side, it's up to you. And then I'm going to rate here Q accept still. Okay. So as per our example, I have considered m is equal to 3. M is equal to 3. If it's m is equal to 3, which is m greater than 3, then m minus 2 has to be 1. So at the end, how my input depth will looks like will be hash, 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 1, hash, hash, hash. Okay. Now only 1 is being left out in our input depth. Hence the output is 1. And then it is reaching the final QX. Okay. So this is first part explained. Now next second part is this is for m is greater than 2. If you consider m is greater than 2, then that has to be the final result. And don't get confused, okay? Let me take m is equal to 4. Let me take m is equal to 4. In that case, this has to be 1, 2, 3, 4, then 0, 1, 2. See here, if you cancel this one, you're going to cancel 1 on this side. If you cancel this one, you're going to cancel 1 on this side. If you cancel this one, you will be searching for another one to be cancelled there. We are not going to find any 1 there. So instead, we are going to replace this 0 by 1. Hence, in the input tab, how many 1s is being left out? 2. So our resultant, right, if m is equal to 4, which is greater than 2, then 4 minus 2, what will be the result? 2. So in our input tab, at the end, there will be 1, 1. This is indicating the answer, okay? So till now, whatever the diagram I have drawn till now, right, this is for m greater than 2. So next one, right, I'm going to add few states with transition for m is less than or equal to 2 cases. So for this one, right, what I'm going to do, for this one, right, what I'm going to do is, suppose m is equal to 0, then delimiter 0 will be there, then 1, then hash. Okay. And then if suppose m is equal to 1, then this is going to be 1, then delimiter, then 1 hash. Okay. If suppose this m is equal to 2, then this has to be 1, delimiter 0, 1. So 1 will be cancelled, this will be cancelled, this will be cancelled, this will be cancelled. At the end, 0 will be left out. No more 1s will be there. Okay. In this case, the condition is different when m is less than or equal to 2 and m is greater than 2. For m is greater than 2, I have designed the transition function, the required transition function. But what about the m is less than or equal to 2? So m is less than or equal to 2, right? This recursive process will keeps on happening there. The recursive process will keeps on happening there. But instead of this 1, right, we're going to get 0 there. Instead of this 1, you might be confused. Those who are understanding from the beginning, right, you may not be confused that much. But those who are entering just now, or maybe just few minutes, or those who are not listening, right, will be very much confused. So let me start for this one. Let me start for this m is equal to 2. Let me start. Let me use different color. One, 0, 1 hash. This is Q naught. This is Q naught. Check in the diagram. Check in the diagram. If you find first 1, then we are cancelling it. It has, and then we are moving towards right side till we find this hash function. In between, we are not disturbing this symbol, zeros and ones, which is Q1, which is Q1, which is Q1. If you're finding any ones and zeros, then do not disturb it. Move towards right side till you find hash. So now, once I find this hash, what I'm doing is I'm moving towards left side, and then if you find one, cancel it, and then keep moving towards left side till you find hash. This is the scenario here. This is the scenario here, Q3. And then once you find hash, what I'm doing is, once you find hash, I'm moving towards right side. I'm moving towards right side. And then I'm canceling this by hash. This is recursive process is happening here. And then at Q1, whenever you find ones and zeros, do not disturb them. Keep moving towards right side. If you find hash, till you find hash, we are moving towards right side. If you find hash, what I'm doing is I'm moving towards left side, and then I'm moving towards left side. 1, this is happening here. Q2, if you find 1, then cancel it by hash, and then keep moving towards left side till you find hash. Okay, now I'm coming back to this one, Q naught. Currently at this position, Q naught. Okay, now currently at this position right now. So Q naught, right? Once I find hash, I'm moving towards right side, and then the recursion here, right? It starts if it begins with 1. But in our case, when m is less than 2, right? We are finding 0 here. We are finding 0 here. Okay, we are finding 0 here. And then what was my our target? What was our target? If you find if m is less than or equal to 2, then the result will be 0. The result will be 0 in our input tab. The result will be 0 in our input tab. Okay. If m is less than or equal to 2, then result will be 0. So now what I'm going to do is, if this 0, I'm going to extend here. If it is instead of 1, if you're finding 0, then if you're finding 0, then I'm replacing that one by hash. And then if you want, keep moving towards right side. If you want, keep moving towards right side. And then, is it confusing or not? I don't know. You please go back and do it, okay? You please go back and do it. Now see here. Now see here, let me rough this one bit. Okay. No, I'm not going to replace this 0 by hash, okay? I'm going to let this 0 as it is. And then after that, this is Q4, because 0 will be the result I'm expecting. 0 is the result I'm expecting. Or if you're confusing, right, I'll do one thing. If 0 means inside the input tab, only blank symbol will be there. Got it? Don't get confused. 0 is delimiter, and then inside nothing is being left out. Nothing is being left out. I mean, inside this one, if I cancel everything, inside this one, if I cancel everything, then only hash symbol will be there. So here I'm going to replace this by hash blank symbol. So m minus 2, if it is m is less than or equal to 2, then this 0 will be replaced to hash. And then if you're finding hash, don't do anything, move towards right side, and then that is the QX. Few might be confusing, I know. Please go back and check it by yourself. Okay, this is, we are designing a Turing machine which can able to compute a function. I'm designing a Turing machine which can compute a function. And then today's functions, right, I have considered subtraction of this kind, I mean m minus 2 like that. In the exam, I may provide you like m minus 3 or m minus 4 with different conditions, okay? So this is a simple Turing machine for computing a function. So various functions are there. Please practice by yourself. Okay. Thank you so much.